So in our class last Thursday, we spent the majority of the time going over the different sections of the IMRD report and answering the really good questions that you guys had about those different sections and kind of what the default would be like and how you might handle questions if a student had resistance or if there was variation in a particular discipline. Now, the readings that were on the agenda for Thursday, which we really didn't get to talk about much, though you brought in some of what you had learned in the reading to bear on class discussion. But the readings were really trying to get you to realize that IMRD is a general framework, but it's not a rigid formula. So it's flexible. There's variation. And this variation tends to be in response to the needs of different discourse communities, where a discourse community is a group of readers and writers that share common values and purposes for the texts that they produce and consume. So when you see variations in IMRD or variations across disciplines, and most disciplines we can consider a discourse community, and then maybe even within a discipline, subdisciplines could be their own particular, more highly specific discourse community. When you see variations, try to connect those variations to the values or needs of those discourse communities as best as you can, because if we can come up with a reason for the variation, it helps contextualize it. It helps make more sense to the student and to yourself why there are these variations. So as an example of what I mean by connecting variations to the values of discourse communities, I want you to take a look at this table here. So this table shows three different citation styles. MLA, which you're probably all familiar with, is commonly used in English, literature, languages, many humanities disciplines. APA, which is used in social sciences, in business, a lot of technical fields, and a lot of scientific fields, actually. And probably across the university, APA is more common than MLA. But everybody tends to know MLA because that's what's taught in first year writing. And then IEEE is for Institute of Electrical Engineering, something with a third E. So this is for much more technical engineering disciplines. Take a look, go ahead and pause the video and take a look at these different citations. So these two rows are for the in-text citation and these are for the works cited. Go ahead and take a look at these and see what conclusions you might draw from what kind of values, why would we have these different disciplinary styles? What does it suggest about what these disciplines value? So when I do this activity in class, usually the first thing people point out is that APA has the year in here. And that makes a lot of sense because in social sciences, APA stands for something psychological association. And in fields like psychology, really recent research matters a lot. Whereas in MLA, which is more literature, it doesn't matter as much when people say something. So for instance, if you're writing about Shakespeare, it doesn't really matter if that text, if your argument about Shakespeare was written in 1980 or 2016. Whereas if, for instance, you are doing research on gender and communication, like a lot of my research, it matters a lot whether something was written or studied in 1980 or 2016. So APA really privileges the year a lot. MLA also privileges page numbers and has much more detail about finding exactly where a quote comes from. Actually, in MLA, I have this example here with page 35, but they usually don't do that in APA, have a lot of page numbers. IEEE, there's no way to cite a page number. It's just not part of the citation practices. Now, next thing people will notice is that IEEE has uses numbers, and it orders the citations. I don't know, there should be a 1 here. There should be 1 and 2. It orders the citations in the order that they appear in the paper. And this makes it possible to do something like 6 through 9. And you can see this is so much more concise than these other ones. And concision is really valued in this technical community. Moreover, authors aren't really valued. That there's much less emphasis on who said it, who came up with it, and more emphasis just on the idea. To the extent that where these two disciplines alphabetize the works cited, in this discipline it should appear in order that they appear in the paper. So the first thing you cite is number 1, and that's number 1 in the works cited. Second thing you cite is number 2, and that's the second item in the works cited. And so this shows that authors aren't as important in these more technical disciplines. There's more based on a more sense that knowledge itself is predominant, and it shouldn't matter who says it. Whereas in MLA, of course, it's very important who says it. So when I talk about trying to link variations that you see to disciplinary values, this is a very good example of what I mean. So now let's go ahead and turn to the reading from chapter 5. And this talks about variations in IMRAD. And one of the biggest variations that you're going to see is the problem solution IMRAD. So up until this point, all of the IMRADs we were looking at were based on experimental studies. However, in applied disciplines like engineering, for instance, the research contribution is really building something new. And so this research structure reflects that. As a matter of fact, if you're getting something in a discipline like engineering, I'd say probably 2/3 to 3/4 of the time, any IMRAD in engineering is going to be a problem solution. They still definitely do experimental research, and that's much more common at the undergraduate level in labs. But when you're working with graduate students on their own research, you're probably going to be seeing a lot of problem solution. Same thing with anything in computer science. That tends to be a lot of problem solution. And so this is a little bit different structure. The introduction is very similar to the introduction of an experimental IMRAD. But we have this whole solution section that's going to have multiple subheadings that are really topic driven, depending on the particular area. Then there will be some kind of evaluation, some kind of miniature methods and results, and usually a section that says conclusion. Now, what I'd like to do is let's go look at these exercises, the abstracts you looked at for in exercise 5.1. Hang on. So I'm going to read this abstract here, and maybe I'll zoom it up a little bit. And I'm going to read it sentence by sentence, talking about what it's doing, and I'm going to go ahead and apply what you've learned in the subsequent chapter, chapter 6, about the novelty moves to kind of explain what's going on. So first we have psychological measures such as pain, anxiety, effort play a crucial role in the evaluation and development of robotic devices. So this is a clear statement of significance, which is part of the introduction here. Psychological data are collected and analyzed, and are often used to inform an iterative tuning process of a device and its controller. So this is a statement of the status quo. Currently, these data are collected, then analyzed offline, such as they are only evaluated after the experiment has ended. So this is starting to signal the gap. This makes any iterative design process tedious, so we're definitely in gap territory here, and time-consuming. These are the main problems. Tuning must be done on a subject-by-subject basis and for a variety of tasks that the device is intended to be used for. Then, to overcome these drawbacks, so this is filling the gap, we are proposing a new type of human-machine interaction. So right here, up through this point, this is about half of the abstract that is dedicated to describing the problem and introducing the motivation for the research. And I think this is pretty common in problem solution abstracts, whereas in abstracts for more experimental research, it's usually a little bit easier to understand the motivation for the research, and so it's a little bit less space. But this is up to about half the abstract, trying to describe the problem, because that is really key. Then about here, and it's okay if you draw the line in a different place, we begin with the solution. So they're proposing, so we could call all of this the solution. The important thing is not that we label things exactly the same, but that we're seeing the same things, regardless of how we label it. So here, we're sort of introducing the solution. They're proposing a new type of human-machine interaction, and it's based on real-time measurement. Then they explain their solution a little more. By continuously monitoring, we propose conducting an optimization. In other words, we pose an optimization that includes the human body in the loop. And then they say what this allows. So here we're getting this part, the solution, right here. Then it's really just the last sentence where we get the evaluation, which is what would be the method and results in a typical experimental study. We validated this concept, so that's a clear statement of evaluation, in an extensive human subject study where, and this is how they did it, and I think this is showing, it's a little unclear to me, but I believe this is showing that they did optimize it and how they did it. I think this could be a little bit clearer statement here. So if you had a little bit of trouble figuring out what they concluded, I think if I had this in a session, I would work on that. Otherwise, I think the rest of the abstract is very, very clear, but maybe a clearer statement of the outcome there. All right, let's look at the next one. Let me again go through this kind of sentence by sentence. So there's a growing concern about greenhouse gas. That's a really clear statement of significance. Really easy, so I understand the overall topic here. Carbon dioxide capture is a promising approach to reduce carbon dioxide emissions. So this is kind of the cutting edge status quo. This is what is currently being done. Then the next sentence, one competitive technology is oxycombustion. So this is an even more promising, even more cutting edge. And they describe what that is. And the next statement gives us a little bit a definition of oxycombustion. Okay. And explains how it worked. Okay. Then they introduce another kind of issue here to improve the performance of these two units. Most studies use SM approaches to investigate the effects of different parameters. If you have this student in a session, you might say that's a little bit unclear, but so they're trying to figure out a way to make these two different parameters, these two different kinds of units speak to each other. Then we get, however, the SM method is very time consuming and only allows a limited number of parameters to be taken into consideration. So this is a gap in the status quo, getting a little bit closer to this person's research. In contrast, equation-oriented methods exploit synergy. So this is a better method. So we're getting at a new sort of cutting-edge status quo. Actually, as I read a little bit below here, I don't think this is the status quo. I think this is where they're beginning their solution. So this would be something that I might recommend to the writer to kind of improve a little bit and make clear. So I think they are bringing equation-oriented methods to the table. I thought there was going to be, this was setting me up to think that there was going to be another gap within equation-oriented methods, but that's kind of where they end up. This is their solution. What I would suggest that this writer do is change it to say something like equation-oriented methods are a promising approach, or this project capitalizes on equation-oriented methods to solve the SM method problem. So to make it clear that this is solution and not that they're starting to articulate another status quo and then that they're going to then complicate by having a little bit more of a gap on here. Okay, so here we have, so really this whole first paragraph, again about half the abstract, is dedicated to setting up the problem and kind of going through different levels of the status quo. So that we're talking about kind of broad level problems with oxycombustion units and well, the broadest problem is carbon dioxide, but we have some problems here with the units and a method that we're using to take into to address these issues. So about half of the abstract is spent focused on articulating the introduction and articulating the problem and getting to the solution here at the end. Then we have a clear statement of the solution. In this thesis, EO methods are used to optimize a two-stage flash CMU. They talk about the equations or the formulations that they develop. Then they build something else, complementary conditions, and they avoid using integer variables. So these are all key parts of their solution that they are choosing to highlight in the abstract. We just have to rely on them, that these are the most important things. And then here we move into the evaluation. To assess our model, we use some sort of analysis to analyze. So this is the method for assessing it. And then here's the results. Our analysis demonstrates a 16% reduction compared to similar systems. So this is clearly not an ideal abstract. It's actually a little bit more iffy. I worked with this student and so boy, this is so much clearer than original, but still has a little bit of ways to go. But overall, it's representative in how much of the abstract is dedicated to understanding the problem and how little of it is dedicated to the evaluation. And both of these, it's just one or two sentences at the end. Now, when we compare that to an experimental IMRD, here's what we get. So, first sentence, users tend to create passwords that are easy to guess. And then a commonly proposed solution, system assigns passwords tend to be hard to remember. So this is stating out the context of the problem. And it's easy, I think, for even a general reader to see why this is a problem. Then they say past phrases have been suggested as a remedy for this. What the abstract doesn't say, what they've left out, is that the goal of the study is to test whether past phrases really are a viable solution to this problem. So that's something that's left out for the sake of economy in an abstract. So these two sentences here are dedicated to the introduction. This should be a research question, and one possible improvement have been suggested as both secure and usable for decades, but they have not been tested. And that's what's been left out. But this hypothesis has not been tested. Now we move into methods. In a 1,400 participant study, we explore the usability of system-assigned passphrases. So this says what they did, how many people they studied, and that it was an online study, and the different things they compared. And here we move into results. Contrary to expectations, system-assigned passphrases perform similarly to system-assigned passwords. Passphrases and passwords were both forgotten at similar rates, led to similar levels of difficulty and annoyance, and participants wrote down a majority of them. Okay, so we're still on results. However, passphrases took longer for participants to enter and required error correction. So this is also the results, some other findings that they have from their study. Moreover, passphrase usability did not seem to increase when they shrunk the dictionary. So they kind of tested another condition, and that also didn't work. So all of this, everything from contrary to expectations down to change the order of words, is the results. So quite a bit, about half of this abstract is focused on results. And then the last sentence is moving to discussion. These results suggest passphrases aren't a good solution, so the hypothesis is not confirmed. So this is typical of a more experimental IMRD abstract, in that the focus is really on the results, and there's much less space dedicated to introducing the research question, hypothesis, or problem. This is really a study that's testing a hypothesis here. So the goal of this exercise right here was to first kind of practice identifying and making sure that we're seeing similar things, similar rhetorical moves going on in here. And you saw a couple places where I had a little bit of confusion which rhetorical move it was, and so those are places where we might work with the writer to improve that. And then the other goal of this was to really see that in a problem solution abstract, we spend a lot of time really kind of dedicated towards understanding the problem, a little bit less space really most of the time to explaining the highlights of whatever solution they implemented, and then one or two sentences evaluating that solution. By contrast, in a more experimental IMRD, the majority of the space is dedicated towards the news of the results. Now, I also want you guys to become aware that while the IMRD is kind of an ideal framework, there's lots of variation in the various section names. But everything still follows the general hourglass format, where the introduction's broad, explains the motivation, then we get into the details, what they did, how they tested it or what they found, and then back out again to what does this mean? What are the implications? What is maybe the next step?